Hello! Hello, friends from YouTube. Today we are going to see a teardown of Dynamics DL4.2i controller. You see it? That's it. So this is a Dynamic for DL4.2i controller, which we are going to make a teardown. These are the engines, the DC motors and the wheels that are coming with the motor, with the controller, sorry. This is the entire system, the entire electrical system from a wheelchair, electrical wheelchair from handicapped persons. And today we are going to see how it works. Okay, so first we are going to show you the controller. The controller is made from aluminum die-cast housing on both sides, so keeps everything very cool and helps dissipate all the thermal energy that is generated by the MOSFETs inside. We have the next controllers. Let's zoom in a little bit and look. So we have the power, yes, the battery indicator, and the on-off switch. So you have here, you push it, and you have the indicator of the battery. This is the joystick, forward, reverse, left or right, and here we have, let's turn it on, off, sorry. We have power, general power potentiometer here. So in case you run out of battery, you can put it on half. So to be sure that you are going to get home and put it to charge. Okay, it has a very nice picture here as a gas station, something like that. Here is the connector for the charging unit, and here we have a 7-pin, so 2, 4, 6, 7 pin plus the exterior, so we can say that it has 8 electrical connection. This is for diagnostic and programming. You can use a handheld programming unit that you connect it here, and you can adjust or troubleshoot the unit. Also, if you have any idea what kind of system, what kind of interface slash programmer can be used here, please leave a comment below, because I look on the eBay and in general on Google, and I find only 5 pins and 3 pins like this one, a plug like this one. So I didn't find with 7 pins. So if you have any idea what kind of programming unit can be used to program this, please let me know, because I didn't find it. Okay, this is the housing. Okay, we have a plug here. It's a general plug. You can take it out. You know, it's the system is connected with these 2 bolts on a side of the wheelchair, so you can operate it with only one hand. And this is the connector. We put it back. It has 4. Let's zoom it a little bit. you have 4 pins and a middle pin, so you can be sure that you don't put it backwards or something like that to blow something else. So okay, let's zoom back. We put it back here, and now here we have the power connector. I will take this out. We have here 24 volts from 2 batteries that are next to my feet. So we have here 3 connection, plus, minus, and one that is going I think on a switch, on a sensor, if you want to say like this, so that when you charge this, the system automatically don't allow you to use the wheelchair, you know, in case you are plugged in, to break the plug or something like that. So in case you put it and forgot and you want to go, I think this gets a signal that is charging and is not allowing you to move. Okay, we put it back, plus and minus, no spark, so everything is good. Another thing that I want to show you is the engines. The DC motors that are here. Okay, now let's zoom a little bit. We have a Frankmo engine, which is a 24 volts, 11.3 amps. You cannot see it, but no, not 11. Rest you cannot see very good. I think it's 11.6 or one. No. Yes, 11.7 amps. So this is a very powerful engine. Here we have the clutch. So now it's connected, the wheel with the electrical engine, and now it's not connected. So you can push the wheelchair in case you run out of battery. We put it back. Again, it's locked. I mean, it's connected. We put it here. We zoom out, and let's do a small test to see how it goes. By the way, this is the brake. Let's zoom again. Like this. And if you look like here, you almost can put here a screwdriver. Almost. But when you turn it on and just a little bit touch it, this is connecting with this. The disc that is connected to the DC motor shaft is here inside. So now it's closed. So you have a brake. Okay. You have a brake, it's braking the engine, but when this is, you see, you almost see it, if you look closer, how it's moving. So this is the brake. There is a relay inside of the controller that I will show you in just a minute. Zoom out, and now let's play a little bit. So we have forward. Let's give more juice on the maximum. I mean, so this is maximum. Forward, backwards, left, and right. Okay, now it's not going as it should be because I will show you in just a minute. We're going to take the plug out, so no power, no DC engines, no nothing. Now we're going to look inside. Let's push this a little bit and look inside. I already take the 4 screws. The screws look like this. So you have a cross type screw, and then we have it like this and do it like this, and we open it. As I said before, aluminium cast, so everything is good. Inside, let's zoom. No, zoom, focus. Okay, so we have a choke here, a black choke, and we have one DC engine and another DC engines. And do you want to know how we can tell this? Because we cannot see the wires going there, but we see here this black shape, square shape plastic ferrite with a field detector, one here and one here. So this is around the connector. These are field detectors, so it measures the current that is going in one and the other engine. So this is for measuring the current. The relay, when it's clicking, this is connecting power with the brakes. A piezo for sounding different alarm. You have here 1, 2, 3 and 4 screws that are keeping this part of the board tight on the aluminum chassis, because here we can find the MOSFETs under, so we can take all the board and you will find the MOSFETs here. And also here we have the processor, the potentiometer for power, and here is the connector for diagnostic interface. This is the connector for the joystick. Sorry, this is for charging. My bad. And this is for the programming interface. So sorry about that. Okay, let me show you the inside of the potentiometer. So I already take out the screws. We have one here, and one here. Sorry, one here, and one here. And you just pull it out like this. And it's going back like this. We take the plug out, put it on the side, and this is the front panel. I already took the screws out so that I can do this. Here we have the switch for power, and here we have the LED array for battery indicator. So we have this thing. We have some rubber here. We take it out, and we have the front. We have this that is making in such a way that you don't go off the grid, you know, with the label, so that you don't give false indicators. I will tell you in just a minute the electrical things that are happening inside here. So you see it has a spring, and when you push it, it's going like this. Okay, okay. Inside we have 4 coils and 1 main coil in the middle. So you have 1, 2, 3, 4. North, south, east, west, whatever you want to call it. We have 2 circuits. They are TLC274C and 14053B. So this is the circuit inside, and a small potentiometer here. And how it works: we have 6 wires, plus, minus, these 2. So these 2 wires. This is for power, 5 volts. And here we have yellow, brown, blue and white, each in the normal position like this. Each 4 wires has exactly 2 volts in the middle, 2.1 maybe, but usually 2 volts. When you push it like this, for example, you have it like this and you push it forward. In one wire you have 0, in one and in the other you have 4 volts, not 5, 4 volts. If you take this, you have 5, but the system is entering in a protection situation, because thinks that this is bad. So that's why it's important to have this and to not be wear down or broken or something like that. So you really have to follow this shape which is inside. So you have 0 on one side, on one coil, and in the other you have 4. No, like this. You have 0 volts, for example, in this coil, and in the other one you have 4 volts. If you do like this, in the other you have 0 volts, and in this one you have 4 volts. So it's measuring the differences. So we have 4 pins that are going directly to the microprocessor, and it's making differences between one and the other one. And so that's how it steers, because it's not only for forward and backwards, it's also for braking and slowing, and not braking, and slowing the speed on one wheel and accelerating the other one when you turn. So this is very interesting, you know. Usually you see 2 potentiometers in the middle, so when you push it you go full resistance, and the other one minimum resistance or 0. So it's very interesting and well made thing. So this is the potentiometer. Something else that I want to speak with you is this bridge. This bridge is the one that is controlling the array of transistors, of MOSFETs. You have impaired the MOSFETs, so you have 4 on each engine. So this is a 4-channel circuit that is delivering 2 channels on one H bridge, and the other 2 channels from another H bridge for the second DC engine. So it's very interesting and well designed and simple also, because I'm working in the forklift, electrical forklift fixing business, and I fix this, and I see very complicated and it's sometimes very hard to, even for an experienced person, to fix something like that, because you see a lot of things for protection and something like that, mainly for the system itself, not for the operator or something like that. What keeps the operator safe are some basic systems for security, but here we see that it's very simple. Is only oriented for protection for himself, for the controller, so no operator, except the soft start. So when you push it at once, the throttle in the front, you don't go at maximum speed in half a second. You go in stages if you want. So this is the controller. So thank you very much for seeing this video. I hope was helpful for you. And if you have any questions in troubleshooting, fixing, again about the interface, if you have any idea what kind of interface can be used for this, let me know. Put a comment below and I will reply as soon as possible with a thank you and everything else. So again, thank you very much, and hope to see you again on a different occasion, because when I'm planning to build something or to fix, I think that from now on I will make a video with everything that I'm fixing or modifying or just having here, and want to show you guys how is inside of one, and some problems or ideas of how to fix it or modify it. So thank you very much and have a blasting day, and don't forget, you can do a lot of things with this kind of gadgets, because for example this one, I'm planning to build a tank, and I will use this original system. I will put two servos, one forward and backwards and one for left and right, and I will use multi-channel remote control and use it to steer, you know, and it's going to be a very fun, and maybe I will make a video. So on the end, please subscribe and please give me some thumbs up, because I really need some money to spare on this kind of things. So remember to take a click there. So thank you very much and have a blasting day.